This video is on quadratic applications. We're going to look at some problems that are involving gravity. When we have problems involving gravity, this becomes a physics problem, and we have a very set equation we have to use. For problems involving gravity, we use the form h of t, because this is height at time t. So h of t means height at time t. Then we have our variables of t squared and t in there so that we know this not y's and x's. They are the same thing, but we're using height at time t. That's why we have to use h of t and not just y. The first part of our gravity equation, when we have it as t squared, our a value is actually negative g. Now, we'll never actually put negative g. We'll always have a number here. But this is actually, in physics, this is what we call our force of gravity. Force of gravity. There are two types of two ways we write gravity. We use feet per second or meters per second. So when we are using feet, we always put the number as negative 16. So this number will become negative 16 if we use feet per second. So if we see the word feet, we know we're going to use a negative 16 in this entire location. Or if we see the word meters, we're going to use the entire number of negative 4.9. And it's going to be meters per second. The reason this happens is because in physics, it's actually a negative half of the gravity. So gravity is 32 feet per second squared. And in meters, it's 9.8 meters per second squared. So what happens here is we're actually taking half of that value, and that's where we get the negative 16 and the negative 4.9. We just have to know if we're dealing with feet or meters. So it's very, very important that you read the problem carefully and know your units. But it will still be in seconds. We just have to know if we're dealing with feet or meters. The next part that's attached to your t value, so your b value, is v sub 0. V sub 0. This stands for the initial velocity. So it's initial upward velocity. So velocity starts with a v, so if we see that it's being shot upwards, so we can see that how fast it's going as it's going up. And then it'll come back down because of the force of gravity. The last part, which is our constant, is still your y-intercept, so we call this h sub 0. H sub 0 is the initial height. So h sub 0 represents the initial height. This will still always be your y-intercept. So that doesn't change. We're just saying it as initial height, or h sub 0. So we're just going to look at a couple problems where it says state the initial height and the initial velocity of the objects. So if we're given an equation that says an object is launched into the air and the equation s of t is equal to 39.2 t minus 4.9 t squared, gives the height in meters after t seconds. So since it says meters, that's where that negative 4.9 comes from, because it's negative 4.9 if we're using meters. This is your gravity part. This part represents our gravity. The initial velocity is the b value, so the one attached to just the single t. So the initial velocity comes from that 39.2 t. So we would say initial velocity. So we want to find the initial height and initial velocity. The initial height comes from our constant. So if you notice, there is no other number. There's no constant in here. That means that our initial height is 0 meters. We have to make sure we do use the correct units. And then our initial velocity is at 39.2. And it's meters per second. We put m/second. We know it's meters because it says meters, and it's for every second. So our initial height was our constant at 0, and then our initial velocity is the b value at 39.2, and it's meters per second. Question 2 says a water balloon is catapulted into the air so that its height h in feet. So since it says feet, that tells us that we're going to have the negative 16, and that's where we have that negative 16. After t seconds is h equals negative 16t squared plus 192t plus 5. So we look for the initial height, which is always our constant, so that's at 5. So our initial height is that 5, and it's in feet. We always need to know our units. Then we look for our velocity, because it's being catapulted, it's being shot through the air, it has to have velocity. It's our b value, which is attached to just t. That's 192. And that's feet per second, because it's always per second. So we use feet because that is the units that they're using. So it's very important that we look for what units are being used. So on these next couple problems, it says write an equation h of t that represents the height after the objects do something. So we're going to actually write the equation, and then on a couple we're going to solve. This is still using gravity. So on question 3, it says a cannon mounted on top of a 75-meter tall building, or tall fortress, so it's meter, launches a shot upwards in the air at an initial velocity of 29 meters per second. This tells us we're using meters, so since we're using meters, we have to use the negative 4.9. It then tells us our initial velocity of 29, and it does still say meters per second. It tells us 75 meter tall, so that tells us where it actually starts from, and we have 29 meters per second. So our equation is h of t is equal to, since it's meters, we're using negative 4.9 t squared. That comes from our meters. Then we have our initial velocity, so it's plus, we have 29 t. Then plus, we want our initial height, which was at that 75, because that's where it started from. So our initial height, then we also had our initial velocity, and then because it's in meters, that's how we knew it was negative 4.9. Each of those pieces tell us how to write our equation. On question 4, it says a volleyball player hits the ball upwards at a velocity of 28 feet per second. So we have velocity of 28, but then it says feet per second. Feet per second tells us what part of the gravity we're going to use. Then it says the player jumped upward to hit the ball 8 feet in the air. So we're going to use the feet per second equation. So it's going to be h of t equals negative 16 t squared. That's because it was feet. Then we would need our velocity of 28 t, because that's our b value, plus our initial height from when she hit the ball. It was at 8, so we're going to have plus 8. So again, our initial height came from there. We knew that it was negative 16 because it was feet per second, and we had our initial velocity because it tells us velocity at 28. So we have h of t equals negative 16 t squared plus 28t plus 8. We have to be able to write the equation to be able to solve the equation. So for question 5, it actually asks us to solve the equation. So if an object is dropped from a 30-foot window, so we're told 30 feet, it's dropped from that, 30 feet, because it's in feet, we know we're going to use the negative 16. Approximately how long will the object be in the air? So because it's being dropped, it's not being shot up. There is no velocity. There is no velocity. That's important here. we need to be able to write the equation h of t is equal to, since we're dealing with feet, it's negative 16 t squared plus the velocity, because it's being dropped, it's not being, the upward velocity is not being shot up, so there's no velocity, but it's starting at 30 feet. So this is our actual equation. We can rewrite this as just negative 16 t squared plus 30, but this is our actual equation. So if we were to solve this, because it does ask us to say approximately how long will the object be in the air, so how long will it be in the air? So the question's really asking how long, so the y value, will it be in the air? That's asking us, when will it finally hit the ground? When will the ground, this height at time, be 0? So we'll have 0 equals negative 16 t squared plus 0t, that's gone, plus 30. So we want to solve for this. So I'll subtract the 30 to the other side. Because I only have one letter t in here, I can solve this just using basic StatMap. So I'll have negative 30 equals negative 16 t squared. I'll divide by negative 16, so I'll end up having a positive 30 divided by a positive 16 equals t squared, because a negative divided by negative. And then to solve for t, I'll take the square root. Now remember that when you take the square root of both sides, you have to have a plus or minus, and this will equal to our t. So if I take the square root of 30 over 16, let me get a calculator, the square root of 30 divided by 16, close my parentheses, I'll get 1 37/100. So I will have 1 37/100. So I have a positive 1 37/100 and I have a negative 1 37/100. But remember, time can't be negative. So the time will be approximately 1 37/100 seconds in the air, because that's when it hits the ground. So if I've just dropped it from up here and it's going to hit the ground, I need to know how long from here to here was. And that was 1 37/100 seconds. So we had to write the equation to be able to answer the question. So on question 6, it says find the maximum height reached by a golf ball that is launched off of a 0.2 feet t. So again, we have feet here. That tells us which gravity part we're going to use. We're also told the initial height, because that's where it's starting from, with an upward velocity of 54 feet per second. So we can write our equation, h of t equals, since it's feet, we're going to have the negative 16 t squared plus, our velocity is 54 t plus, our initial height was 0.2. So this is our original equation. And so now to actually figure out the question. It says to find the maximum height. Maximum height is the y value. So I just want to find the maximum, and I'm going to use my calculator. So let's go put this in, maximum from calc, or Desmos. We can also use Desmos, but I'm going to use the calculator to do this one. So I'm going to go to y equals, I'm going to put in negative 16x squared, because I can't put in t, plus 54x plus 0.2. So I'm going to look at the graph of this and see what happens. Okay, so I cannot see that maximum. I know the maximum should be up here. So I'm going to zoom fit so that it fits the window. Zoom fit, and let's see what happens. I have to press enter after that. And now my vertex will be up here. So I don't need to actually be able to see it completely. I just got to be able to find it using the calculator. So I'll do second. I want to calculate. I want to find the maximum. So I want to click number 4. Now, it says left bound, so I'm going to press the left arrow key, and my cursor is moving, and it's on the left side of my vertex, because my vertex should be around here. So it's on the left side. So I'm going to press enter, and now it says right bound. So I'm going to press the right arrow key until my cursor is on the right side of my graph, so that it is in fact on the right side of my vertex. I'm just going to hold it. I'm still just holding it. So now my cursor is on this side, and I know for a fact it's on the right side. So I'll press enter. And I don't want to try and guess on this, so I'm going to press enter again. So the vertex from the calculator is 1.69, 45.76. So I'm going to write that down. So the maximum from the calculator was 1.69, 45.76. So it asked for the maximum height, which was the y value. So the maximum height would be approximately 45 and 76/100 feet is the maximum height that golf ball will reach. So we had to write the equation to be able to come up with the answer, but we can find the answer using the calculator. I could have used Desmos and just clicked on the vertex, and that would have probably saved time, but I wanted to do it in the calculator as well.